Hello, algebra students. Mr. Zacek here. We're beginning a new unit on rational functions and rational expressions. And when we see the word rational, um, we want to think about the root of that word, which is the word ratio. And a ratio is a comparison of two numbers, which, if they were a to b, we could write it as a to b, or we can write as a fraction. And so when we think back to our definition of a rational number is any number that can be written as a fraction. So when we talk about ratios, we're talking about expressions that are going to be written as a fraction. Well, we get this word undefined here that we need to be concerned about. And when a fraction has a denominator of 0, we can't define that. How do you divide something 0 ways? It's not possible to do that, so it doesn't have a definition. So the first thing as we start to look at our unit on rational expressions is we have to identify the excluded value for each rational function and expression. And the excluded value is going to be the value that makes the denominator equal to 0. Denominator equal to 0. So it's the value that makes the denominator equal to 0. That's the excluded value. It's not going to be a part of our domain. So we're going to do a few of these here. We got a lot of examples. I'm not going to do all of them. But the process is very simple. It's that we set the denominator equal to 0 and solve. So in number 1, x equals 0 is the excluded value. In number 2, what's the denominator? Well, set it equal to 0 and solve. X equals 0 would be the excluded value. Obviously, 3 would be the same, so let's jump to number 4. Now, if you plug 0 in for x, it wouldn't come out to be 0. So what we do is we set the denominator equal to 0 and solve. So in this case, we're going to add 2, and x equals 2 is the excluded value. So I'm just going to pick a couple of these ones. If we look at number 7, we've got x minus 5. So we set the denominator equal to 0 and solve. Okay, that's the excluded value. Now, again, why is that excluded? Well, let's look. What would happen if you plugged in that value? You'd get y equals 7 over 0, which is undefined. So that's why we're excluding that number. Now, you can try some of these on your own, but again, I'm not going to do all of these. We'll do number 9 here. So set the denominator equal to 0, and then solve that equation. So we want to subtract 3. 8x is negative 3, and divide by 8. I'm just going to leave that as a fraction. X equals negative 8/3. Now, it starts to get a little bit more involved when we get into some quadratic expressions for a denominator, like we have in number 10. And so in number 10, we've got here. Now, the question of solving this, we're going to have to factor. And remember, when you're factoring, you always want to look first for a GCF, greatest common factor. So as I look at this equation here, I see that x is common to both of them, and x to the first power. So I'm going to divide by that GCF. So it's going to now be x minus 15 equals 0. So remember, you subtract the exponents when you are dividing. And now you have to set both sides equal to 0. So when you solve that, you get 15. So it's possible for us to have more than one excluded value. In this case, it would be x equals 0, and it would be x equals 15. Those would be the two excluded values. They would be values that we don't include in our domain. I'm going to leave some for you to work on, but let's take a look at number 13 here. Now in 13, we've got k squared plus 7k plus 12. There's our denominator, set it equal to 0. So we look first for a GCF. We don't see a GCF, so now we're looking at our value of A and our value of C. So A is 1, so that's 1 and 1. C, the factors of C are 1 and 12, 2 and 6, 3 and 4. And because this is a plus sign in front of the 12, we're going to add to get positive 7. Well, what does that? 1 times 3 and 1 times 4. So it's k plus 3 times k plus 4. So we're going to get some work back with our factoring here again. So we set those both equal to 0. K plus 3 equals 0. K plus 4 equals 0. Whoops, not x. K. So now k, that would be negative 3, and k would be negative 4. So our excluded values would be k equals negative 3 and k equals negative 4. So again, it's possible to have more than one excluded value, and we need to think about that as we're working through this unit here on rational functions. And you can go and do those other ones for some more practice. Now, in addition to identifying excluded values, we also want to be able to simplify each rational expression if possible. And as we look at this, we want to think separately about our numbers versus our variables. So remember, there's different rules for how we simplify and how we divide numbers and how we divide variables. With variables, often what we're going to be doing is we're going to be subtracting the exponents. And you'll see what I mean here in a moment as we look at some examples. Alright, so in the first one, we've got 2 and we've got 14. So we can think of this as 2 over 14 times r to the 4th over r. We just separate that so we can really isolate what we're doing. Well, let's look for common factors. So 2 goes into itself once and into 14 7 times. Now we have r to the 4th and r to the 1st. So when we subtract that, here it's 4 minus 1, so it's r to the 3rd. Now the thing you have to be careful of is where does that end up? So notice r to the 3rd is in the numerator and 7 is in the denominator. So we want to leave it there in those places. A lot of times people just arbitrarily move those, and that would be incorrect. So we look at number 2. We've got 5 over 15 times m squared over m. Now you don't have to separate them like this, but I'm just doing this right now to really illustrate that point. Do we have a common factor with 5 and 15? We do. 5 goes into itself once and into 15 3 times. And then m to the 1st and m to the 2nd. Subtract those exponents and we're left with m to the 1st. Now really pay attention to where is the m. It's in the numerator. And where is the 3? It's in the denominator, so we leave that as m over 3. Okay, now, as you looked at 1 and 2, what you had is a monomial divided by a monomial. That means just one term divided by one term. But when we get into number 3 here, now we've got a binomial, 2 terms, divided by a monomial. So the first thing that we want to do in this instance is I want to write these as two separate fractions, where 4 is our denominator for both. And now I'm going to look and see, can I simplify those individually? As I look at the first one, 3 and 4 have no common factors, so I can't simplify them. But the 6 and 4 do. They have 2 as a common factor. So 2 goes into 6 3 times and into 4 2 times. So we could simplify this as 3/4 x plus 3/2. Same thing with number 4. We've got a binomial and a monomial. So 5x over 5x minus 35 over 5x. Okay. So as we look at this, anything divided by itself is 1. So that first term is just going to become 1. And now in the second term, 5 goes into itself once and into 35 7 times. So minus, now be careful, it's 7 over x. It's not 7x. So we want to separate those and we want to simplify them. Again, I'm not going to do all of these, but I just want to pick a few to look at here. So we see we continue to have a binomial divided by a monomial. So I'm going to do number 5 here. So it's 2x squared divided by 10x minus 6x over 10x. So I want to simplify both of those. So look at the first one. 2 and 10 have a common factor of 2. And now x and x squared, that just becomes x. And then in the second term, 6 and 10 have a common factor of 2. 2 goes into 6 3 times, into 10 5 times. And the x's divide and become 1. Now those are multiplying, so it's really not going to change the value. At this point, it becomes really important that we identify where those things are. So in the first term, it's 1 times x, which is just x divided by 5, minus 3 times 1 is 3, over 5 times 1 is 5. Okay. So 6, 7, and 8, very similar type things. I'll let you do those. Now when we get to number 9, what we have in number 9 is a trinomial, 3 terms, but it's the same concept. 6x cubed minus 12x squared minus 6x, all of those are going to have that same denominator of 6x. So now it becomes simplifying 3 separate monomials. So the 6's go into each other. X to the cubed divided by x becomes x squared. 6 goes into 12 2 times. X and x squared just becomes x. Anything over itself is 1. So this simplifies to become x squared minus 2x minus 1. And you just have to pay attention to your where those things are. You can kind of get lost in a little bit of confusion if we're not careful to really identify closely what those values are. All right, 10, very similar to 9. I'll let you try that one. Now, it gets different when we get to 11 because now the binomial is in the denominator. So what we want to do in this instance is the first thing you want to do is factor the binomial. So 4x, what's a common factor in this term here? Well, 4x and 4. 4 is going to go into both of those. And when you divide them by 4, it becomes x plus 2. So let me rewrite that again. It's 4x over 4 times x plus 2. Now the key here to this is the 4 in the parentheses are being multiplied together. So what you can do in that case is I can divide the common factor of 4 and 4. So we have here left in our numerator x over x plus 2. Now, you cannot cross out the x's because the x is, it's got to be the same like monomial. There, it's a binomial. And I'll say it like this, they're married together. So you can't cancel out the x's. It's married, this x is married to the 2, and it would have to be exactly the same. All right, so let's try a couple more of these here, just because this is a little bit different. So number 12, again, monomial over a binomial. So I'm looking to factor, common factor of 7. So I write that 7 in front, and it becomes d plus 2. So now this 7 that's in the front is a, just get my highlighter here, that one can cancel out because it's not tied to the other one by addition or subtraction. So 7 divided by 7 is 1. So this equals d over d plus 2. And again, don't cross those d's out. They're married. The d plus 2 is married, and it can only be exactly. Okay? Now, as we look at number 14, we want to see, hey, is there anything I can factor in the numerator as well? And what do we have? We got a GCF up there of 12. So I have 12, and then it's going to be a plus b. What's the GCF in the denominator? 3a and 3b. Well, 3 is the common factor, and here it is now, a plus b. Now, let's simplify. Well, 3 goes into itself once and into 12 4 times. And then the a plus b and the a plus b, that's exactly the same. So in that instance, you can cross that out again. If it's exactly the same, what's being added, you can cancel those two out there. And so you want to pay attention to that. All right, we're going to do one more, and then I'll let you work on the other ones here. Let's do 15. All right, can we factor the numerator? Well, let's look at our numerator. 6 and 3. Well, 3 is going to go into it. How about any other common factors? 3n. So 6n squared plus 3n. Now when we divide that by 3n, our GCF, we get 2n plus 1. Hey, look at that. Our denominator is 2n plus 1. What do we have? Something that's exactly the same, so those two can cancel each other out. All right, and what I'd like you to do is go through and work through those other questions on here. Go back and use these as a guide. So we're looking at what are values we have to exclude and how can we simplify. And this is day 1 of Unit 11.